Section 2.2, Factoring, Part 3. So in the previous video, we looked at factoring by grouping. Now we're going to focus on factoring trinomials. In a trinomial has three terms. And so again, you always want to check if you can factor a GCF. If you can, you want to do that first. But once you see that you have three terms, then we're going to follow this process here or this process. So first we'll focus on this process when we have a coefficient in front of x squared of 1. Okay, so in a quadratic expression like this, we're going to focus on the general form. And so a is going to be the number in front of x squared, b is the number in front of x, and c is your constant. So what you want to do here is you want to take your constant, in this case -6, and we're going to list all the factors that give us a -6. So for example, 1 times -6 gives me a -6. -1 times 6 gives me a -6. 2 times -3 gives me a -6. And -2 times 3 gives me a -6. So that is your first step. So step 1. Step 2, you want to look at the coefficient in front of the variable x. And as you can see here, we have a -1. So we want to then go ahead and add these factors and see which of these combinations will give us a -1. So 1 plus -6, -5, -1 plus 6, 5, 2 plus -3, -1, -2 plus 3 is +1. So again, we're interested in a -1. So we can see that the factors 2 and -3 will give me that -1. Okay, so that is step 2. Then for your final step, we want to factor this, and we're going to write 2 parentheses. In order to get an x squared, I would have to multiply x times x, and then I'm going to use these 2 factors. So I'm going to have a +2 and a -3. So we can say that x squared minus x minus 6 is equal to these 2 factors. Okay, let's look at the next example. So first we look at the constant, which is 60. And we want to write all the factors that will give us a 60. Notice that your signs here are both positive. So anything that we work with here needs to be positive. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Our goal is to get this 16 if I add or subtract these factors. So I'm going to start with adding. 1 plus 60 is 61, 2 plus 30 is 32, 3 plus 20 is 23, 4 plus 15 is 19, 5 plus 12 is 17, 6 plus 10 is 16. So here we can see that these 2 factors, 6 and 10, will produce our 16. So we can write x squared plus 16x plus 60 is equal to x times x, and then I'm going to use these 2 factors, plus 6 and plus 10. If you're not sure if you're doing this correctly, you can check your work. If you multiply x times x, you get x squared. X times 10 is 10x. 6 times x is 6x, so 10 plus 6 would give you 16. And 6 times 10 would be 60. Okay, let's go on to the next one. Here we have a 12. But notice that your signs are negative and positive. In order for this to be a positive, that means that we would have to multiply these 2 numbers, would have to have the same sign. So a positive and positive will make it positive. Negative and negative would also make it positive. So since we have a combination of negative and positive, then you want to look at all those factors. So we would have 1 times 12. -1 times -12 gives me +12. 2 times 6, -2 times -6. We have 3 times 4 and -3 times -4. So again, in order to get a +12, the signs have to be the same. So either both positive or both negative. Then we're going to add, our goal is to have a negative 7. And so 1 plus 12 is 13. Negative 1 plus negative 12 is negative 13. 2 plus 6 is 8. Negative 2 plus negative 6 is negative 8. 3 plus 4 is 7. Negative 3 plus negative 4 is negative 7. We are interested in negative 7, so we'll use these two factors. So x squared minus 7x plus 12 is equal to x times x, which would give me x squared, and then I'm going to use my two factors. Now let's look at what happens if we have a coefficient other than 1. So if we have a 2, a 3, a decimal, anything other than 1. So to do that, we're going to be combining a method that we looked at in the previous video, factoring by grouping. Okay. So the idea here is going to be to somehow end up with 4 terms so that we can use grouping. There are other ways to do this. You can do a guess and check, for example, but I'm going to show you this method. General form, ax squared plus bx plus c. And so the first step we're going to do is we're going to multiply the coefficient a times the constant c. And so whatever this term is, this is what we're going to be interested in to begin the process. So a times c. So in our example, we have 2 times negative 4. And 2 times negative 4 gives us a negative 8. So I'm going to take my negative 8 and I'm going to follow the same process that we did earlier. So how can we get a negative 8? 1 times negative 8, negative 1 times 8, 2 times negative 4, negative 2 times 4. Our goal is going to be to also end up with a negative 7. And so if we add these, 1 plus negative 8 is negative 7. And so you can see that the terms that we're interested in, or the factors, would be a 1 and a negative 8. So what we want to do is, in our problem over here, instead of writing a negative 7x, we're going to rewrite it using the factors of 1 and negative 8. So this polynomial will now become a positive x for the 1 and a minus 8x for this second factor. And then we have our minus 4. So what we have done is we have created a polynomial with 4 terms instead of 3 terms. So again, notice that negative 7x, we just replaced it with x minus 8x. So what we can do next is we can write down these 4 terms, we can group them. So I'm going to group this term and these terms. Okay, so we look at 2x squared and x. What do they have in common? What's their greatest common factor? And that's going to be an x. So I'm going to factor out an x. So if I factor out an x from here, we get 2x plus, factor out the x, we get a 1. Our goal is to have the same thing on the second parentheses. And so the common factor of 8 and 4 is going to be 4. And then we need to decide, is this a negative or positive? We should have a negative 8. So 4 times 2. In order for that to be negative, I would need a negative here. So negative 4 times 2 is 8x, negative 8x. And negative 4 times 1 is negative 4. So now you can see that we have this factor and this factor are common. So we can factor it out. So we're going to have 2x plus 1. If I factor out of this term, I would end up with x. And if I factor out of here, then I would end up with a minus 4. So here we have that this polynomial is equal to 2x plus 1, x minus 4. So let me just rewrite the whole equation. So let's try another example. So the first step is to multiply 2 times negative 15, and we get negative 30. Then we're going to list the factors. 1 times negative 30, negative 1 times 30, 2 times negative 15, negative 2 times 15, 3 times negative 10, negative 3 times 10, 5 times negative 6, and negative 5 times 6. What we're interested in here is to have a positive 1. So this right here is going to be 1 plus negative 30, negative 29, 29, negative 13, 13, negative 7, 7. 5 plus negative 6 is negative 1. Negative 5 plus 6 is positive 1. So we're interested in this positive 1. So when I write my polynomial, then we're going to write it as, instead of this positive x, we're going to replace it with a minus 5x and a positive 6x. And then we have minus 15. So now we can group these two terms, and we can group these two terms. And so we're going to have the common factor here is an x. So we're left with 2x minus 5. The common factor of 6 and 15 is going to be a 3. 3 times 2 is 6x. 3 times 5 is 15. We want the 6x to be positive. So I'm going to need a positive here. I can factor out a 2x minus 5. If I do this, then I'm left with an x plus 3. Okay, let's try example 17. So we have a 3 times a negative 8 is negative 24. So we want to list all the factors for negative 24. And we can keep going, but notice here that we want a 10x. So we already have enough information. So I'm just going to put some dots here to show you that this continues. But here, 1 plus negative 24 is negative 23. 2 plus negative 12 is negative 10. Negative 2 plus 12 is 10. We want a positive 10, so we're going to use negative 2 and 12. So we're going to rewrite this polynomial as 3x squared plus, instead of 10x, we're going to write a minus 2. So we have 3x squared minus 2x plus 12x minus 8. So we're going to group the polynomials. We'll group this one and this one. So if we look at this first part, they have in common, greatest common factor is an x, so we end up with 3x minus 2. And the 12 and the 8, the greatest common factor there is a 4. So 4 times 3 is 12x. 4 times negative 2 is negative 8. We want the 12 to be positive. So that would be addition here, plus 4 times 3. Positive 4 times 3 is positive 12. And now they have in common a 3x minus 2, which we can factor out. And that's going to leave me with an x plus 4. Okay, so now we're going to look at some polynomials with two terms. Okay, so we've done the 3 terms, 4 terms. Again, with the 2 terms, first thing is a GCF. If you have one, factor it out. If you don't, it's okay. We move on. You look at your polynomial. It has 2 terms, so then we're going to do a difference of squares, or it could be a sum or difference of 2 cubes. Difference of squares is used the most here, and we have it up here. The difference of squares is just a squared minus b squared can be factored out as a plus b times a minus b. Okay, so if we have here x squared minus 9, then we can see that we have 2 terms and we have a square. So we're going to use difference of squares. So we're going to use this formula. And so one way to look at this is here we have x squared minus the 9. The 9, we can write it as a 3 squared. And so using this formula, we would have x minus 3 and 1x plus 3. Okay, so when you see that you have a 9, 9 is what we call a perfect square. We can get 9 by multiplying the same number, 3 times 3. So one parenthesis would be a negative, one would be a positive. So if we look at this one, p squared minus 36, Ask yourself, is 36 a perfect square? In other words, can we multiply the same number to get 36? And we can multiply 6 times 6. So 1 would be negative and the other would be positive. Here we have m squared minus 100. So m squared minus 100, we know it's going to be two parentheses. It's m times m, but the 100 is a perfect square, so we get it from multiplying 10 times 10. So one would be positive and one would be negative. Now on this one, we don't have numbers, but it's okay. We have squares here. So that tells us that these are perfect squares. And so we're going to have, I always like to write my two parentheses. In order to get an r squared, I'm going to need r times r. In order to get an m squared, I'm going to need m times m. Since they're difference of squares, one is positive and one is negative. So let me just rewrite it here so we can see it better. So we have r plus m, r minus m. Okay, let's try a couple more. So here we have x squared minus n squared y squared. These are perfect squares. How do we know it has two terms and all the terms are squared? So in order to get an x squared, I need to multiply x times x. In order to get an n squared, I would have to multiply n times n, and y squared would be a y times y. One is positive, one is negative. And the last one here, again, these are all squares. So we're going to have x times x. To get a y squared, we need a y times y. And r squared would be an r times r. And a p squared would be p times p. One's positive, one's negative. And then lastly here, whenever you have a polynomial that is in this form, u squared plus 2uv plus v squared, we can factor it out as u plus v squared. And if it's a minus here instead, it would be u minus v squared. And then for sum or difference of two cubes, we would use these formulas here. Okay. That says factor each expression. So number one, you can still do the previous method. 1 times 9, 3 times 3. We want to have a 6, so the only one that would give us a 6 would be 3 plus 3, which is 6. So x squared plus 6x plus 9 is going to be equal to x plus 3 plus x plus 3. Notice that these are the same, so we can write it as x plus 3 squared. Let's look at the next one here. So same idea, we have 9. So instead of 3 plus 3, we can use a negative 3 and a negative 3. So I'm going to have x times x minus 3 and minus 3. So we get x minus 3 squared since we have 2. The x cubed plus 8, we can use this formula here. And the reason is the 8 can be written as 2 cubed. So if we write it this way, then we can use this formula here. So the first part is to get u plus v. In this case, we have an x and a 2. So we can write it as x plus 2. Then it tells us to square the u. In our case, we're going to square the x. Then we're going to have a minus u times v. So x times 2 is 2x. And then we're going to square the v. In our case, 2. So 2 squared is going to be 4. Okay, let's try some more examples. So here we have 4 terms. So remember, when you have 4 terms, you want to factor by grouping. But first, we should always check, is there a greatest common factor? And the reason for that is it might make it easier once we simplify. And so here, let's go ahead and if we look at the 3, 18, 4, and 24, the only common factor there is a 1. So we'll go ahead and use grouping. So for 3p cubed and 18p squared, the greatest common factor would be a p squared and a 3. So if I factor out a 3p squared from 3p cubed, I'm left with a p. And if I factor out a 3 from the 18, I'm left with a 6. And on this side, I'm hoping to get the same thing. The greatest common factor of 4 and 24 is 4. I need the 4 to be negative. So negative 4p is negative 4p, negative 4 and negative 6 is 24. They have a p minus 6 in common, so we can factor that out. If I factor p minus 6 out, I'm left with 3p squared and minus 4. Here we have 3 terms. So I'm going to take my negative 30 and find the terms here. So I can write all the factors. And we're interested in having a negative 1. And so that's going to be given by this number here. 5 plus negative 6 is a negative 1. So this polynomial is going to be x times x. And then I'm going to use a positive 5 and a negative 6. And you can check your work if you want to make sure. The letter C, we have 3 terms. I have a number in front of 3. So I'm going to use grouping here. A times C is negative 30. And so I already listed the factors over here. We can use the same thing. So we wanted 13 here. So we're going to use the negative 2 and the 15. So this would be equal to. So we're going to use grouping, right? So we're going to rewrite this as 3x squared plus a negative 2x plus a 15x minus 10. And then we're going to group this term and this term. So the common factor here is going to be an x. So we end up with 3x minus 2. And the greatest common factor of 15 and 10 is 5. 5 times 3 is 15. 5 times negative 2 is negative 10. And they have in common the 3x minus 2, leaving me with an x plus 5. Okay, so if we look at letter D, we have 4 terms. So we can use factor by grouping, or you can also factor out a greatest common factor of 3. I'm going to go ahead and use grouping. So for these 2 terms, they have in common a 6t squared. So that would leave me with a t squared minus a 3. And these 2 terms have a 3 in common. So that would leave me with a t minus 13. I need the 3 to be a negative 3t. So I'm going to make this a negative 3 times t is negative 3t. But negative and negative will make this a positive. So I'm going to change this to positive so that we get a negative 39. Notice that these are not common to both, so we will leave our answer as is. Okay, here we have 2 terms. So 49 is a perfect square, 7 times 7. So we can write this as n minus 7 and n plus 7. And these are also perfect squares. So we can write this as, to get an h squared, that would be h times h. A y squared would be y times y. A z squared would be z times z. And k times k. One is going to be positive and one's going to be negative. So again, when factoring, you want to check to see where you're at and then try one of the methods.